You are welcome to Unit 11, Lesson 2, dy dx. Unit 11, Lesson 2, dy dx. Let's look at the curve. If you look at this curve very well, you will see that there's a similarity between what we were doing when we were looking for the gradient function and now when you are differentiating using dy dx. You look at it very well on the curve, there is a tangent. A tangent is a straight line drawn on the curve. And you discover that around this tangent we have 2 points, P and Q. And also, we now have an horizontal ds. At this point, it is an arrow. So which means from P to arrow is now ds. And from this point to this point, we can label it st, which means from t to p, we have x squared. And x squared actually means it is along the vertical line, and therefore y is simply x squared. So therefore, we now have from q to x is simply y plus dy, which means from arrow to s is y, and from q to arrow is dy. So from this 0.0 component, we can say that from 0 to x is simply what? X plus what? Dx. So right now, we are going to handle the equation of the curve y equals to s squared. So we are looking at what? First equation, y equals to s squared. So you will discover that in solving this equation, now what you have now is y plus dy is equals to what? X plus dx all squared. So you now have just the same way that you have been working, but a little bit of sincerity now. So you have y plus dy. You expand this from our usual way of expansion. You are going to have s squared plus 2s dx plus dx all squared. So that is what you will be having. You are going to have s squared plus 2s dx plus dx squared. So what do? You move y to this way so that you can have dy. So we can say now that dy is now equal to x squared plus 2x dx plus dx all squared minus y. Now you should know what y is. Go back to your equation. You now discover that dy is equals to s squared plus 2x dx plus dx all squared minus x squared. So you now have an equation, and look at it properly if you can cancel out anything. You discover that s squared will die with minus s squared. So the y is equals to 2x dx plus dx all squared. Now, which means we can bring out the x. So we have the y is equals to the x bracket 2x plus the x. Because dx multiplied by dx is dx squared. So we divide through by dx. So we now have dy dx. This is where you have your differentiation now. Dy dx, which is now equal to 2x plus dx. So we can now say as x tends to ds, ds tends to 0. So therefore, we can now say that dy dx is equals to 2x. So that's the first. Thank you. I'm ready. Let's look at the second equation. Differentiate 3x squared minus x plus 5 with respect to what you see w dot arrow dot t is called with respect to x from the first equation. So I will want to write what I mean by w dot arrow dot t. It simply means with respect to. So I want to divide that 10. So WR dot T is with respect to. So when you see this acronym, know that it is with respect to. So differentiate 3x squared minus x plus 5 with respect to x from the first principles. So we will now write the equation is y equal to 3x squared minus x plus 5. That is the equation. So what do? It now become y plus dy is equal to 3 into x plus dx. So let me use the one that to look the same. So x plus the x all squared minus x plus dx plus 5. So that is what you have. So if we do the expansion, we simply have y plus dy equals to 3. You have known and become x squared plus 2x dx plus dx all squared. That will do the bracket and now become minus bracket x plus dx plus 5. So we can now do the expansion. Let's do the expansion. Y plus dy will give us 3x squared plus 6x dx plus 3 dx all squared minus x minus dx plus y. So, what do we do at this juncture? Look at it. So, we can bring out dy. So, dy is equal to 3x squared plus 6x dx plus 3 dx squared minus x minus dx plus 5 minus y. So what is y? That equation y is equal to 3x squared minus x plus 5. So what you have there now become dy is equal to 3x squared plus 6x dx plus 3 dx squared minus x minus dx plus 5 minus, we will now put y, and that y is simply 3x squared minus x plus 5. So let's try and see how we can straighten it out. We have the y is equal to 3x squared plus 6x dx plus 3 dx squared minus x minus dx plus 5 minus 3x squared plus x minus 5. So having done this, let's see whether we can do the cancellation. 3x squared minus 3x squared will cancel. Minus x plus x will cancel. Plus 5 minus 5 will cancel. So what do you have? You have dy is equal to 6x dx plus 3 into dx all squared. See anyone remaining again? Minus dx minus dx. So let's check. We have 6x dx plus 3 into dx all squared. You have minus dx. So that's what you have. So now we've gotten that, let's bring out the dx. If we do that, we are going to get the y equals to ds into 6x plus 3 dx s into 6s plus 3 into dx squared. They now become minus 1 because of the ds that have been brought out. So carefully, we cannot say now that we are dividing both sides by ds, which means the y all over dx is equal to the x 6x plus 3 into dx all squared minus 1 all over dx. Then we are going to clean the top. So we can say now dy dx equal to dx into 6x x plus 3 into the x all squared minus 1 all over the x. The x will cancel the x. What you have now is y over the x is equal to 6x plus 3 the x all squared minus 1. So as x tends to the x, as x tends to the x, use the x tends to 0. Therefore, the y, the x is equals to 6x minus 1. Thank you.